Welcome to another safety class, and today we're going to talk about one of the very important issues in safety, which is fall protection. As we have mentioned before, OSHA right now focuses on 4 areas that cause most of the injuries and the fatalities in the construction industry, and these 4, which are called the focus 4 areas, are fall protection, electrocution, caught in between, and struck by. So we have initially talked about caught in between, and that can be something related to excavation, for example, cave-ins of trenches and things like that. So today we're going to talk about fall protection, which is Subpart M of our code. Just having a look at this picture here, for example, we see some laborers standing on some scaffolding at a relatively high level. So it's definitely above 6 feet from the ground. They are not protected in any way from falling. So if any one of them falls, there might be an injury or even a fatality if they fall on their heads or things like that. So this is definitely a fall hazard, and it causes a violation. And as you can see, we have 3 employees working in this area, so that's 3 violations at the same time. So the workers could fall while climbing on the shoring structure to set it up and remove it. Ladders and lifts must be provided in addition to fall protection, as we're going to discuss it in a minute. Here's another example. A carpenter working on some formwork, and he's getting close to an open end, and he doesn't have any fall protection protective equipment. So again, and we can see also the power cable around him for his drill, and if he trips on that cable, he might fall, and again, that's probably at the 2nd floor level, so there might be an injury here as well. So workers must be protected from falls over 6 feet. That's one of the magic numbers that we're going to learn about in this lecture. And workers are exposed to a fall hazard greater than 6 feet while working near stairwell opening. So that open edge, that they definitely need to be protected. A third example here, also on residential construction here, we have someone working on the 2nd level floor with an open edge around them, and it doesn't seem that they have any fall protection whatsoever. So here again, unprotected open-sided floor 6 feet or more above ground level. There should be a guardrail system and safety net system for personal fall arrest system or personal fall arrest system or PFAS. Any one of these would be required to stop the fall in case that person falls from that location. This is definitely, obviously, again, a violation here. Working at a relatively high level, we're talking here about at least 20 feet from the ground, and no protection whatsoever. They're working on a sloped roof, open edge, so definitely workers are installing new metal roof without fall protection. So again, obviously there's a problem here. We can see there's a ladder in the background, and it seems that the ladder is fine. It's extending 3 feet beyond or above the landing area. I'm not sure whether it's tied in here or not, and whether it's resting on a flat surface or not, but again, the ladder seems okay, but obviously we have a problem with fall protection, or the lack of fall protection devices. Another example here we have, again, obviously there's no one working in the area, but we have what seems to be a guardrail, but there's no mid-rail. So again, that can be a fall hazard. So the photo shows, this is the floor actually, this is not the mid-rail, shows a guardrail and a mid-rail and a toe-board are missing on an open-sided floor of a building. This could expose workers to a 12-foot tall fall, and toe boards are required to protect workers below from falling objects. Again, if something falls from this level on the workers below, that can also cause an injury. Same thing here, working on a platform, working on a scaffold above 6 feet, no fall protection whatsoever, and even this set of blocks, again, some of it may fall and injure people standing underneath this scaffold. So lack of fall protection for workers on fabricated frame scaffolds. Planks appear to be overloaded and there's no safe access for workers. The workers are exposed to a 35-foot fall hazard from scaffold while stacking blocks prior to overhand bricklaying operations. Another example here, we're having a ladder leading to something like a walkway that's not very well fortified or reinforced. Definitely these tapes are not going to be resisting a 200-pound force as is required for the guardrails. And someone to access this level, they have to step on that top of the ladder, which should not be used whatsoever. The ladder should extend 3 feet above or beyond the landing surface. So several violations here. So the ladder to work platform is not of sufficient length. It must extend 3 feet above the working surface. Another one, standing on the top of the ladder, which should not do, above 6 feet, no fall protection. Here again, more than 6 feet, no guardrails for the window, no fall protection devices for this person, no hard hat for this one here at the bottom, several problems. So workers working from a carpenter's scaffold that has no guardrails extends too far beyond either end, is not wide enough. Worker does not have proper access to the scaffold. How did he get there? Just by jumping or climbing from the window. The worker inside of the window is not provided with fall protection. There's no standard guardrail, and the worker working below is exposed to the struck by hazards of tools and equipment falling from the employees working above. He is not wearing a hard hat. Another example here. Although this one seems to be wearing some sort of fall protection device, maybe that's a harness, but this one is not. Open edge above 6 feet, no guardrails. Rambo is working on that sloped roof. Again, that rope cannot be considered a fall protection device. God knows how high above the ground that is. This is definitely not a hard hat. Another example here as well. Walking on that walkway, no guardrails. This is definitely above 6 feet. So all of these were examples of fall protection violations. All of these can lead to falls, which lead to injuries or fatalities. So these are some of the appendices that are associated with this subpart. Appendix A determining roof widths, Appendix B talking about guardrail systems, Appendix C talking about personal fall arrest systems or PFAS, Appendix D talking about positioning device systems which cannot be used as fall protection, and Appendix E small sample fall protection plans, because again we should have a plan that's observed and maintained by a competent person. Some fatal facts about falls. The falls are the leading cause of death. Falls have been and continue to be the leading cause of death in construction. In 2010, for example, based on statistics from the Bureau of Labor Statistics, we had 370 people killed on construction sites resulting from falls. Most fatalities occur when the employees fall from open-sided floors and through floor openings. This is very dangerous. We have several hazards here. We have a hazard of impalement because of these rebars protruding from the slabs like that. So if that person falls on the rebar, they can penetrate their chest and kill them. This is an open end. Obviously, he's standing beyond the guardrail, which does not have a mid-rail. So several violations here. He does not have any fall protection devices. Falls from as little as 4 to 6 feet can cause serious lost time accidents and sometimes death. If that person falls on his or her head, that can cause death. Or if they fall on an arm or a shoulder or something like that, that can cause some injury. So guards are required at 6 feet. Remember that number. That's the magic number for working on an elevated platform. Open-sided floors and platforms 6 feet or more in height must be guarded. And we're going to talk about the shape of the guardrail. We talked about it briefly when we were talking about stairways and ladders, but we're going to discuss it in more detail in this lecture. Some of the most frequently cited violations related to lack of fall protection measures. 501B1, unprotected sides and edges. We had 1,652 violations. 501B13, fall protection, residential construction 6 feet or more, lack of that fall protection, 1,090 violations. 503A1, fall hazards training program, the lack of a training program, 734. 501B10, fall protection roofing work on low slope roof, 501 violations. And 501B11, fall protection on steep roofs, 289 violations. So Subpart M covers all fall hazards except those which are covered in other subparts, including Subpart L, scaffolds. We're going to discuss that later. Subpart R, steel erection. Subpart V, electrical transmission. Subpart N, cranes and derricks. Subpart S, underground construction, and Subpart X, stairways and ladders, which we have discussed in a previous lecture. The fall protection locations covered by Subpart M, which is what we're discussing right now, are unprotected sides and edges, open edges, leading edges, hoist areas, holes in floors if you're going to have a hole for a stairway or an elevator shaft or some a pipe bank or something like that. Formwork and reinforcing steel, wall openings if you have a window or a door, precast concrete erection, and dangerous equipment, something like a man lift or a scissor lift where an employee stands on an elevated platform to make some usually electrical work or utility work. It also covers ramps, runways, and other walkways, roofs. We define a steep roof as having a slope greater than 4 to 12, and a low slope roof as having a slope less than 4 to 12. Rise over run. The 4 is the rise and the 12 is the run. Protection from falling objects is going to be covered in Subpart M. Overhand bricklaying, one of the areas that cause many problems with fall protection. Excavations, pits, wells, and shafts. And finally, walking and working surfaces not otherwise addressed by any of the previous categories. So in this presentation, we're going to learn when is fall protection required, and we're going to talk about the 4 main methods of fall protection, which might be included as part of the PPE, personal protective equipment, or other safety devices like the safety nets, for example, which are not PPE, but still a fall protection method. So when is fall protection needed? It's needed on all of these, on walkways and ramps, open sides and edges, holes, concrete forms and rebar, excavations, roofs, whether they're low slope or high slope, wall openings, bricklaying, and residential construction. So when we talk about walkways and ramps, the issue here is twofold. One is the person falling from the walkway or the elevated ramp, or tools or equipment falling from that and injuring people standing underneath that ramp or at a lower level. So we have to guard the ramps and the runways and other walkways. To guard them using a guardrail like this one, for example, which has a top rail and a mid rail, and it should also have a toe board at the bottom. So the top rail, we mentioned before, it should be at about 42 inches plus or minus 3 inches, and the mid rail is going to be at the mid height between the top rail and the floor. We're going to need fall protection in residential construction. You must be protected if you can fall more than 6 feet. So obviously this is on the second level, or at least a second level. So there's a height at least here of 6 feet. We don't have a guardrail here, so that's a violation. On unprotected edges, again, if it's above 6 feet, unprotected sides and edges must have guardrails or equivalent. This one does not, so again, this is a violation. Obviously, this is definitely not a guardrail. This cannot be considered a guardrail. It does not resist 200 feet. It does not have a mid rail. It does not have a toe board. So this 1/4 of inch nylon rope alone is not a proper way to guard this open floor. And imagine the height. Here we're talking about probably a 10th floor height or something like that. So definitely a fall from here will definitely result in a fatality. Skylights and other openings in roofs, again, obviously that's a falling hazard. So holes more than 6 feet above lower level must be protected. This opening could be made safe by using a guardrail or a stronger cover to protect from falling. Here we have another hole. Again, it might be for pipes or might be for other purposes, but the hole is not properly covered. So you have to cover completely and securely. If no cover, you have to guard with guardrails. So these are the two options to protect against falls in this hole. When working on concrete forms and around rebar, to place rebar or to work on concrete work, use PFAS, which is the Personal Fall Arrest System. When working on formwork or rebar, cover or cap protruding rebar. So the rebar itself has to be capped to prevent the hazard of impalement. If someone falls on the edge of the rebar, that might penetrate through their chest or their midsection and can cause severe injury or even can kill them. Guard excavations more than 6 feet deep. Again, we see the 6-foot number repeating over and over again. When they are not readily seen because of plant growth or other visual barriers. In addition to needing guarding, this excavation is not properly shored. Obviously, these 2x4s probably are not a proper shoring device. We do not have any excavation boxes. We do not have a proper sloping or banking, and this does not appear to be rock. So definitely it has to have better protection against caving in as well. If you work on roofs and you can fall more than 6 feet, you must be protected. So here we have definitely above 6 feet. So it seems that we have a PFAS here. Whether it's properly tied or not, it doesn't appear from the picture, but that might be okay if it's properly tied. Here we are at the 2nd level or maybe even the 3rd level. We have a wall opening for a future window or door, probably a window, and it's not properly guarded with a guardrail. So if you work near wall opening 6 feet or more above lower levels, you must be protected from falling. So duty to have fall protection is required at 6 feet or greater, protection to be at 6 feet or greater above work or walk surfaces. And you have to inspect the work surface. Walk or work surface is to be inspected prior to work commencing to make sure, for example, there's no slippery material or something that causes trips and so on. Work surface strength, again, if you're going to be working on the cover of a hole, for example, if that's going to be your working surface, then you have to make sure that it's not going to break under the weight of the employee and any tools or equipment used by that employee. So employees can only be on any surface strong enough to adequately support them without failure. When we talk about fall protection options, here we have, for example, 3 different examples. The PFAS, the Personal Fall Arrest System, which is what we're going to call the harness. We're going to discuss all of its details in a few minutes. The guardrails, which we mentioned, consist of 3 parts: the top rail, the mid rail, and the toe board. And we mentioned that that should resist a force of at least 200 pounds. And in case we cannot use the guardrails or the PFAS, there could be a safety net, like the one that you see in the circus, for example. Again, that's going to soften the fall, and it's going to prevent the person from reaching the ground at a high speed, which usually is the cause for injuries and fatalities. For fall protection planning, fall protection systems and work practices must be in place before you start work. So we're not going to start worrying about fall protection after we have already started. You have to plan it in advance. Where are you going to provide your anchor points, for example, if in case we use the PFAS? Where are you going to locate your safety net and how far from the edge, and so on and so forth? We're going to talk about some specifications and some details in this lecture. So here we have the lanyards and the PFAS in use, which is a good practice. These are going to be tied to a point that can stop the fall of that person. Here we don't have any protection, obviously. We have someone working near an opening, no guardrail, no PFAS, no hard hat even. Same thing here, so that's really dangerous. Now look at this picture. This picture I took from my office at another place several years ago, and it shows here some labor resting, one of them resting, observing or whatever, and one is working on top of a roof. Now how high is that roof? Of course here that's a low pitched roof, so low slope, but there's no fall protection whatsoever. Now to give you the full picture, that was the height where they were working. So this is a 3-story building. Obviously I was taking this picture from my office was on the 3rd floor, and that's probably even, so that would be probably the 4th floor, and that's the 5th floor level. So any fall from that height would definitely be fatal. And as you can see, we have a group enjoying the sun and discussing about this roof and the installation of the gutter and so on. So all of that is definitely a violation. So duty to have fall protection at leading edge. Each employee constructing a leading edge 6 feet or more above lower levels must be protected from falls by guardrail systems, safety nets, or personal fall arrest, PFAS, personal fall arrest system. This does not apply to Subpart R, steel erection. We're going to talk about that later on. The 4th method is going to be an alternate plan to these 3, which is a very well developed plan. That's if you can prove that the guardrail is going to impede the work, or that the safety net is going to be impractical in this case, or the personal fall arrest system can cause some encumbrance to the people working and lower their production rate and so on. If you can come up with another plan, which is a safety plan, if the employer can demonstrate infeasibility or greater hazard, then a fall plan must be developed, and the burden of proof in this case is going to be on the employer. First of all, to prove that the first 3 methods cannot be used or are going to be more hazardous to use, and then to come up with a successful plan as an alternative. For precast erection, each employee engaged in erection of precast concrete members 6 feet or more above lower levels, again, must be protected from the falls using one of the 3 suggested methods: the guardrail system, the safety net, or the PFAS. Again, if none of these 3 can work successfully, then the burden of proof is on the employer to come up with the alternative plan. Here we have precast concrete. It seems we have here, I'm not exactly sure whether this is a PFAS or not. It seems we have one, but it doesn't seem to be properly tied to any anchor points. And here we have a ladder. It doesn't seem to be extending 3 feet above the landing surface, if there's going to be a landing surface here. So there might be some issues in this picture. In residential construction, again, same thing. Each employee engaged in residential construction 6 feet or more above lower levels must be protected from falls using one of the 3 systems. If none of them works, then again we have to work with an alternative plan, and the burden of proof, as usual, is on the employer. We talked about the guardrail system. We mentioned that the top rail should be at 42 inches, but we have some flexibility here. If it's up to 45 inches or as low as 39 inches, that's fine. So we have a tolerance of plus or minus 3 inches, and it must meet the 200-pound force resistance requirement. The mid-rail is going to be installed at the mid-level. So if we are at 42, then the mid-rail is going to be at 21. If we are at 40, then it's going to be at 20. If we are at 39, then it's going to be at 19.5. If we are at 45, then it's going to be at 22.5. And it must resist 150 pounds of force. And then we're going to have a 2-board, which is 4 inches high. So a 2x4 can work as a 2-board. And this is an example here. So the 2-board is 3.5 inches, which is a 2x4. The mid-rail height is 21 inches. And the top rail is going to be 42 inches. So here we have, for example, a guardrail that's properly installed. It seems to be strong enough to resist the 200 pounds. It's all around the opening. And it has the top rail, it has the mid-rail, and it has the 2-board. So this is very well constructed. Another one, the ladder extends 3 feet above the landing surface. We have the guardrail system very well installed, and even in a different color so that it can be seen from a distance at all the openings. Now this one's going to get a bad surprise. He's stepping into a hole without even seeing that hole, because he's focusing on what's in front of him or her. Now that hole had a cover, but the cover, and it seems like a good cover, but it was not positioned properly. So again, if someone steps on that, they're going to fall through that hole. So here you have to show how you can position that cover so that it doesn't shift, doesn't move from its place. And now it's properly installed, and it's strong enough for a person to stand on top of it. This is proper protection. Again, it shows here the steps of the installation, and we can see that the cover is much wider than the hole to make sure that we cover the whole open area. Here we have a guardrail. I'm not sure if the toe board is high enough, but might be a little bit short. Now this is not very sturdy. It's not strong enough. I'm not sure if it can meet the 200-pound requirement. This one is well reinforced, so this is a good practice. And since we have installed it away from the opening, then in this case we don't need the toe board, because nothing's going to fall directly on the people standing under this opening. So this is fine. This is fine as well. Here we have a wall opening with no handrail. If someone is leaning out of this window to make any work, they may fall. Here we have a top rail, but no mid-rail and no toe board. And even with the top rail, it's like a C-channel. It's like a metal stud. So yes, it can resist the 200 pounds, but it has sharp edges which might injure the person it's trying to protect. If you're going to use wire rope guardrail, can this be used? It can, because it can provide the 200-pound resistance, but you have to flag it, because it's not going to be visually clear as well seen as 2x4, for example. So you have to flag it for visibility every 6 feet. The wire rope deflection, it may not deflect more than 3 inches maximum, so not below the 39 inches. So you're going to install it at 42 inches, and when you pull it down, it should not deflect more than 3 inches, so the bottom is going to be at the 39, so satisfying the 42 plus or minus 3 inches requirement. So here, for example, we have a wire rope, but obviously that is more than 3 inches, and it's not properly flagged every 6 feet. This one probably is a better one. It's properly flagged, and as you can see, with different color flags, so it can be seen from a distance, and it has enough tension. Most likely it's not going to deflect more than 3 inches. And we have the toe board, we have the mid line as well, mid rope. This one has splicing, so that is not going to work well, because this is going to be a weakness point. It's not strong enough. Most likely it's going to deflect more than 3 inches. Obviously this is not a proper guardrail. It's deflecting under its own weight, so it's not strong enough to resist the 200 pounds. So this is not going to work, and it's spliced, and it has so many defects. Definitely this is not going to work. This cannot be considered as a guardrail. It does not support the 200 pounds. The mid rail or the mid tape or whatever you want to call it is not satisfying the 21-inch average. We don't have a toe board. It's not flagged. So many different problems here. This one seems to be okay, however. So although we don't have, it's missing the toe board, but we have a mid rail and we have a top rail. Now, although here we have the lines and everything, they're not flagged, but now he's working outside of that line, so it defeats the purpose, as if the line doesn't exist. So definitely this is not a good idea. Now, if you're going to be working on stilts, so for example glazers, the ones who are installing glass for windows and things like that, sometimes they use stilts to reach higher levels on the same floor. So if you're going to use stilts, then you have to raise the top rail to match the height of these stilts as well. So when employees are using stilts, the top rail must be increased by an amount equal to the height of the stilts. Here, for example, use chain, gate, and movable guardrail when guardrails are used at hoisting areas. If you're going to have a lift or a winch or a crane, so in this case you need lifting material or equipment, then you're going to use a hoisting, a movable guardrail like a gate to open and close. You can use a chain or a gate or a movable guardrail section that should be placed across the opening. Use PFAS during hoisting operations. When removed to receive, when the guardrail is removed to receive materials, employees must be protected by a PFAS. Now, if you have holes in a floor, even if that hole is small, even if it's 2 inches, so any hole 2 inches or more in diameter must be covered. So if it's going to be for a pipe that's more than 2 inches, it has to be covered. And you have to mark the cover, mark as hole, or it could be color coded. Most likely it's going to be orange, since it's a color that can be very attractive to the eye, so you're going to notice it as soon as you step on that elevated floor. Secure the cover so that it doesn't move on you, and cover to support twice the load that's going to be imposed on it. So if a person is going to be 180 pounds, for example, then this cover of the hole has to withstand a force of 360 pounds. So here, for example, we have a hole that's about maybe 4 inches in diameter. This should be covered. And here's the good cover that has been fixed in place with nails to make sure that it's not going to move. Now this is a plywood cover. It doesn't seem strong enough to support the weight of a person, or twice the weight of a person, so this is not proper. This is an open hole. It's not protected. And again, the cover here, although it's marked as whole and everything, but it's plywood and it's damaged, so it definitely will not withstand twice the weight or twice the load it should be imposed on top of it. Same thing here. So this should be definitely replaced. Here the cover does not cover the whole area, so this is not going to work. So let's pause here, and then we're going to resume this lecture in another file so that it wouldn't be too big of a file. We're going to start talking about PFAS, which is the Personal Fall Protection System, Personal Fall Arrest System, and then we're going to talk about the safety nets, and we're going to talk about the different zones on a roof, for example, and talk about the program, the training program for fall protection. I'll see you in the continuation of this lecture.